there is this exponent property where a product to some exponent is essentially the same thing as the individual products to that exponent. So for example here, b times c raised to the n power is the same thing as b to the n power times c to the n power. To see why this is actually true, we can look at an example. So for example, b times c cubed is the same thing as bc times bc times bc. So essentially, its product times itself 3 times. Of course, we can rearrange this here. So rearranging, we get b times b times b times c times c times c. Since multiplication is commutative, well, b times b times b is the same thing as b cubed. And c times c times c is the same thing as c cubed. So what we've just shown is that bc to the cube is equal to b cubed times c cubed. So this formula seemed to work out. So in general, we say that bc to some power is the same thing as b to the n times c to the n. Now what if it wasn't a product? What if it was a quotient? Like this. Well, for the quotient rule, for exponents, essentially it's saying the same thing. The n can distribute in. So we get b to the n divided by c to the n. To see this, we can look at an example. So let's say we had this example. B divided by C all cubed. Well, what is this again? Well, this is B divided by C times B divided by C times B divided by C 3 times. So we have a common denominator of C, so we can just group everything together. And of course, B times B times B is B cubed, just as it was over here. C times C times C is also C cubed. So we have just shown that B divided by C to the third power is the same thing as b to the third power divided by c to the third power. So in general, we can see that b divided by c to the n is just equal to b to the n divided by c to the n. So the n can just distribute in to each of the quotients.